Hello YouTube and welcome to the second GeoSn0w's reverse engineering tutorial. And in our directory we have three files: readme, tool and tool.c. and if you look at this tool file, it is a macOS 64-bit binary, so if we try to execute it, we cannot execute it in Linux. So let's go ahead and create a binary that we can run. So I'm just gonna go ahead and compile the source code given to us. So if you noticed, I've created a new binary instead of replacing the old binary. That is because we'll be needing this old binary as well. So let me just go ahead and give the permissions real quick. Bam, we're ready. So I'm gonna fire up Rreverse 2 against old binary, and if we look at the disassembly, we do have all the information that we require to do the debugging. However, we cannot do the debugging because this binary is not executable in Linux, so we cannot execute even for debugging purposes. So the advantage of this binary is that it has this text strings that we need, as opposed to our Linux binary. So if I go ahead and fire up Rreverse against our Linux binary, which is tool 2, and let's see the disassembly, it is basically a little difficult to do it in here. So for these purposes, we're not going to use, for the debugging purpose, we're not going to use Rreverse, but we're going to use Rreverse to get an idea of the program. So moving on to the source code of the program, tool.c, you would see that what happens is that it takes an argument, and if you don't give an argument, you're gonna have to, it's gonna validate it, and once you give the argument, it's gonna check whether it's equal to this value right here, this hex variable. It's gonna convert it to depending on the input, this hex variable right here will be determined, and this hex variable will be compared to this value right here, and if you give the right key, you're gonna land in here. So we don't have the key, we don't have the right key, and we can't be bothered to find it. So we're gonna have to bypass this condition right here and land in this condition right here. So in order to do that, we'll be using the GDB compiler. Make sure you use the right binary this time. It's the Linux binary. What we're gonna do is we're gonna check in our Rreverse to what's happening, as to what is happening right here. We see the comparison that occurs right here, right above the welcome message string. So we have the comparison right here, and this number here is gonna take us a long way, so keep that number in mind. And if we look at the jump if not equals function statement right here, it is going to, we're going to land in this string right here. The access key is not correct if this jump if not equal statement is executed. So we have the process, the background, what is happening. We have a clear idea on what is happening right now. So we need to look for this number right here and a comparison. So let's go ahead and make a breakpoint in GDB on the Linux binary. So I'm gonna start off at main. Let's go ahead and run it. I'm going to disassemble the main method, and we would see that this jump, or if not equals, we see this desired number here, and there's a comparison right there, and we're gonna copy this address right here. So we need to execute from this point onwards. If we look at the registers, we would see that the RIP is set to this value, which is also like the beginning of our main method. So it is set to, the pointer is set to the beginning of our main method right here. So we need to set it to the jump, or to start off from this statement right here. So let's go ahead and set our RIP value to this number right there, this hexadecimal value right there, and let's just verify that our change took place. Let's just go ahead and see the registers, and see this is our old reference versus our new reference. So let's just go ahead and double check whether we got that reference right. 548B7, 548B7. So we are good to go. We have stopped the program at the breakpoint, if you remember, and at this point we have reached the breakpoint. So now we need to continue the program to see our output, and bam, we've done it. We have arrived at our destination. We are executing this part of the program that would ideally be executed by a person who has the key. So there you have it. We bypassed the condition and we have arrived at our destination. So that is it for now, and I will be doing the other tutorial on level 3, which is also pretty similar to this one, so stay tuned for that. You can find the links that you need to know to get this tutorial done listed in the description below. So if you have any questions, comment below, and hope you have a good day. Thanks for watching.